Okay, so I'm going to present two talks that are somewhat unrelated. One is finished and is forthcoming, the other is just beginning. The one commonality is they both involve population scale measures of networks and population scale experiments. So my collaborators on the Wormholes paper are Patrick Park and Josh Blumenstock, who is in information science at Berkeley. Patrick is a postdoc at Michigan. And the Parallel Worlds project is with Sebastian Derry, Alex Ruck, and Natalie Tong, all graduate students in our lab at Cornell. So what are wormholes? By wormholes we mean high bandwidth social ties that span really large network distances, where network distance is measured as range. So range is the second shortest path between two adjacent nodes. So, you know, if the Lincoln Tunnel is closed, how far would you have to drive to get back and forth to New Jersey? And so you can see it here. The adjacent nodes are in red. The range is shown in blue, and you can count the number of hops. And so by a wormhole, we mean a very long range tie that is also high bandwidth. We measure bandwidth by frequency of interaction and also by the affective strength of the tie. So here's to give you a picture of what wormholes look like. This is the Singapore Twitter network, which we illustrated simply because it's a kind of Singapore's a kind of petri dish for network analysis. It's relatively small, but nevertheless, the network data gives you a nice way of seeing the network of an entire country. And the inset has been blown up to show you a tie that is above median strength and also eight steps if you were to cut the tie. So it has range 8 and median strength. And then this brain-like structure below it is the entire Singapore network randomized down for visualization and showing in yellow the wormholes that are long range and high strength, high bandwidth. So that's what we're measuring here, and we're doing this in order to provide or allow for a population scale test of Granovetter's famous theory of the strength of weak ties, which is, as I'm sure everyone knows, one of the most important, consequential, widely cited papers in all of social science. And it has been tested, but only tested with relatively small network data of the sizes that we have typically been able to measure in the past, like villages, schools, and workplaces. And therefore, the distance measure has mainly been embeddedness, just how many common neighbors. And the result that has been shown in previous studies is that as the embeddedness goes down, so too does the strength. Strength increases with the number of common neighbors. But what we're doing is to extend this to population scale, where we can measure range above the ranges that you can measure in a local network, like a village. So you would be hard-pressed to find a range greater than 4 in a small network, but we can, in population scale networks, extend that. So we want to see what happens then at population scale as we can measure range at greater distances. And we're using 11 population scale networks from around the world. 8 of these are based on Twitter data, where a tie is an at-mention in at least one at-mention in each direction. It has to be reciprocated. And the strength is the frequency of interaction and the affective strength of the tie. The phone logs are for the UK, Afghanistan, and Rwanda, based on phone logs that the carriers provided. And the Twitter data is data that we collected ourselves. Yes, Matt?
Just a question of clarification about the tie strength, because
Yeah.
that's really important, I think, for the art.
Uh-huh.
What is the emotional frequency of interaction? What is emotional investment?
The affective strength, which we measured with Luke on the Twitter
So
data.
if you mentioned someone else, did you mention them with like positive words?
So in the messages that were exchanged with the partner, what were the numbers of high affect words in those tweets?
So it could be negative or positive affect?
Correct.
It's the degree of that.
Yeah. Well, we did both. We did positive, negative, and total. Yeah. So here's what we found. So first, we find that Granovetter is right about the ranges that are available to us to measure in small networks. And as we go from range 2 to range 3, and even up to 4, there is indeed the decline in tie strength that is predicted in Granovetter's theory. So very strong evidence here to support that theory over the distances for which the data were available at the time that theory was advanced. But then look what happens when we go out beyond range 3 or 4. We find the strength actually increases again. And by the time we get up to really long-range ties, the strength of the ties in terms of frequency of interaction is approaching the strength of embedded ties. So they are really quite strong. And the pattern is consistent across all 11 countries. We have not been able to find a country where we don't see this. And it's across two very different kinds of networks. Phone networks, which have very complete representations of the population, and Twitter networks that vary from fairly complete down to much lower market penetration of Twitter. So it's a very robust result across all these different cases. And then this is the affective strength here. This is from measuring with affect words in Pennebaker's Linguistic Inquiry and Word Count Dictionary. And here again you see that the emotional strength is increasing with the range of the ties. This is only for Great Britain and the US, where we had English language. We were able to do this for a few other countries as well, but and the results are consistent with this, but this is just for those two. So why are these ties so surprisingly strong, counter to what is predicted in this theory of the strength of weak ties? So these are three explanations which we have not been able to support. So we don't see strong empirical evidence either for the theory that, well, long-range ties are instrumental. They're not social. It's your tie to your interior decorator or stockbroker or somebody that's just not connected to the rest of your life. And so using work-related ties versus night and weekend ties, we're not seeing support for that. Another explanation is that, well, maybe it's just spatial distance as a confound for network distance, and we tested that using geolocated data for both phones and Twitter, and it's not the case. It's not accounted for by spatial distance. And the most important, I think, of these explanations, and most provocative perhaps, is just missing data. That since we don't have the entire network, we're missing both nodes and edges, and maybe that's the explanation. But we did the same kind of trick that Matt talked about earlier today. We just downsized our data and then grew it back to see if we could get more and more data, would the results get weaker, and it isn't the case. So it does not look to be that it's an artifact of missing data. Here are the two explanations, though, that we do find support for. One is just network multiplexity, different types of relationships. And here we have we see some it's not very complete, but at least suggestive evidence that that for a kind of tie-breaking hypothesis or tie-stretching hypothesis that might be a consequence of maybe social mobility, where the the edges around a relationship might fall away. So someone that you knew in elementary school or even earlier, and all your common friends you've broken the ties, but you still have that really tight friendship. And the evidence that we have here is sort of mostly anecdotal, but Steve Strogatz wrote a book about it. So he has a book about his friendship with his math teacher from high school. And he talks about how it's unembedded and it's just sort of off by itself with a very strong tie. And then another explanation is that these wormholes tend to connect low-degree nodes on the periphery of the network for the reason that you've only got 24/7. You can only spread your time out among a limited number of neighbors. So the fewer the neighbors, the stronger the ties, and the fewer the neighbors, the fewer the possibilities there are for embeddedness. So that would account for it. And we find some evidence that that is the case. And this, in turn, has a really interesting implication that social networks are not just integrated by hubs. If this peripheral node hypothesis turns out to be supported with further research, it suggests that these peripheral nodes may also play a very important role in integrating social networks and in speeding up diffusion. So that's the social wormholes paper. Should be published, I think, sometime toward mid to late November. And the other project I want to present is our study on parallel worlds. And it's nice to have both Duncan and Matt here because they really are the inspiration for this study, the Music Lab study from back in 2006, where they used multiple worlds to test the predictability of cultural winners. And I think everyone here knows the design, so I'm going to just wave my hands at it. But the 8 worlds where there's social influence, the 1 world where there's not. And the interesting result is that there was high agreement within the worlds about which were the better songs and which were the worst, but there was disagreement between worlds. And what we're doing is we're calling our study Party Lab. We're going from a univariate study of culture to a bivariate study of political polarization. And so in Party Lab, what we want to see is, will there be within-world political disagreement as opposed to within-world cultural agreement? So we're looking actually for division within the worlds instead of consensus. So here are our hypotheses. First is that polarization will be greater in the worlds with social influence than in the independent world. Second is that the sign and magnitude of the correlations will vary between worlds, so that in one world it's the liberals who favor the policy, but in the other world it's the conservatives that favor that very same policy. And finally, the third and maybe the most important of these 3 hypotheses, the stronger the predictability within worlds on average, the greater the between-world unpredictability. So just wrap your head around that for a moment. That's, in some ways, I think, the most important motivation for this study. So unfortunately, I cannot give you the results because we haven't collected the data, but we have run some pilots. And so at the risk of presenting information that turns out to be completely wrong, I'll share with you what we know, at least from piloting. It's pretty limited. So we have pilot data here for 3 worlds, really small because we were really just testing the design. So there are only 20 people in each world, exactly split between Democrat and Republican in every case. And in each world, the participants who were recruited through Turk Prime, they are given 20 survey items on the equivalent of indie politics. So whereas Music Lab used indie music that people were not familiar with, we're using indie policies that people are not familiar with. And so these are the 20 policies. So it's on things like cryptocurrencies, where there's no known Democrat and Republican position on that. Whereas if we used gun control, obviously there would be. So these were all pre-tested to make sure that A, people don't have a strong opinion about it, and B, there's not a clear partisan alignment on those. So here's just an example of what the participants see. They're given a bar chart showing the partisan agreement and disagreement, and then they're asked, given their party affiliation, do you agree or disagree? And so here it's a little hard to see, but the dotted lines, vertical lines, are separating the 20 items. The stars are those where there is a big difference between the worlds, so where one world differs from the other, bars pointing off in different directions. And you'll see that the bars that point off in different directions are generally the longest bars, which was our hypothesis 3. And here, this is just a more condensed version of that, that as the within-world polarization goes up, so too do the between-world differences go up. The outliers being a question about using AI for public defenders and the Bitcoin one. Clearly, you could go through and eliminate 4 of those points and get rid of most of that positive relationship. So this is, really preliminary, but suggestive. I mean, you can also eliminate another 4 and strengthen the relationship. So who knows what we'll find when we have the real data. At any rate, it's encouraging at least that there is this somewhat counterintuitive relationship between the extent of the polarization within worlds and the unpredictability between them. So the implication then, the more polarized the issue, it becomes more plausible to attribute this to party ideology, because, well, it would make sense, right? If there's a strong polarization, there must be something about being Democrat and Republican to explain it. But if this result holds up when we run the full experiment, it's saying no, that's not the case. When there's a strong polarization, actually that could be evidence that it was a cascade that produced this, this pattern, and hence the instability from one world to another. So predictability increases with the magnitude of the party differences within worlds, but decreases between that. And then the idea that an observed correlation, it can be spurious not just because of the, the unobserved heterogeneity, the specification error of the model, but also unobserved cascades. Because when we collect survey data, we're not collecting data on the cascade in the underlying population that produced those correlations. And those could also be a reason for the correlation as a spurious effect. And that is it. Yes, Duncan.
I can't wait to see the results. But now that I'm thinking about it, I find that your hypothesis very plausible and appealing. But why should you then expect to see such differences in polarization across the questions?
Right. So there's a lot of luck involved in how this happens. So the reason we're getting the correlations, at least in an abstract model of this, is the sensitivity of these cascades to initial perturbations. Those first, second, third movers have undue influence on the trajectory of a path-dependent process. And law of small numbers being what it is, almost anything can happen in those first 2 or 3 movers that can send the cascade off in these very different directions. And so so part of it then is going to just be luck of the draw as to whether or not there was a sequence at the beginning that sent a cascade off in an extreme direction. Whereas, for example, what could easily happen is that the first mover is a Democrat and they agree, and the second mover is a Republican and they agree, and the Democrats and the Republicans both pile on to agreement, sheer luck, And yet on that item, there will not be big party differences. But if the second mover was a Republican and disagreed, then it goes off in very different directions. And so it could be nothing more than chance. And indeed, in some ways, the hidden message of this is that in social science, at least, the default explanation for much of what we observe that entails cascades and social influence could just be chance. And maybe we need to learn to live with that.
But following on from that, so imagine you did that experiment many times for many groups for each question, right?
Yeah.
So you would sample all of the possible, outcomes driven by luck for each question, right? Would you expect all the questions to produce similar?
Well, so there is also another reason why they can differ, which is intrinsic. And that is that some of these questions may also have the equivalent of what you had with music, which you called intrinsic appeal. And so there could be some intrinsic elective affinity between certain policies and Democrats and Republicans that has nothing to do with social influence. And that could vary from item to item. So for example, some of these items, although unfamiliar, they have the word regulation in them. And as soon as you put the word regulation in there, you probably bias this thing at least a little bit toward a partisan difference that is then conservative for us. So, we need to avoid that. And to the extent that we put it in, it makes it harder for us to get a result. So it's a bias against our finding, not in favor of it. Yes, Victor.
I'd like clarification on what's going on when you have increasing inner world polarization, why that would then lead to between world
good question.
polarization.
The hypothesis here is, or the assumption is, that the intrinsic appeal or attraction of things with other things is generally weaker than the correlations that you will get from a cascade. That is, so if we take the music example, which might be a little more intuitive than politics, the extent to which a group of people, of 1,400 people, would agree on which indie songs are really the best and which are the worst, they're not going to be random. There's some agreement, but it's not going to be that strong compared to the level of agreement that you get from piling on to early movers. I think the same thing will happen with politics, that the intrinsic, maybe with the exception of the items that mention regulation, that the intrinsic partisan affiliation or affinity of these items is just nowhere near as strong as the effect of a cascade where people are learning to oppose that policy because it's associated with my political enemies. That's a stronger mechanism. And so then the implication of all this is be wary of really low p-values. So when you get a p of 0.05, that might actually be more reassuring than a p of 0.0001, because the 0.05 is in the sort of realm of what we might expect with the intrinsic properties of the things we study. But if you get a really small p-value based on a really strong correlation, and there's social influence in cascades as a possible explanation, you need to think, could it have just been a cascade? And it's not actually what I'm attributing that correlation to. Yes, Matt.
So, I'm also very sympathetic to the idea of cascades in the experiment. And then I wonder, though, about in the observational data, the survey data that exists in the world, would this model you're proposing in the experiments would suggest that the survey answers would be sort of uncorrelated, like that there's a correlation in people's attitudes about different political opinions. It's not random that some issues are won and some. I think that has a whole paper on that. So how does that?
Well, wait a minute. Dan and I have a paper on it.
You have a paper on that also.
That is based on
about, so that you know about this correlation.
Yes,
so how does the lack
don't
of
you want to know why liberals drink lattes?
Yes. So the fact that how do you reconcile that empirical fact that has been well demonstrated
by lots of people,
lots of people in this room, with this argument that.
Well, this is so in our paper, this was one of our explanations for why we found these widespread correlations between party and positions that people would take on lifestyle and cultural and moral issues, we said it could be that there's not an intrinsic reason for it, but it is indeed the effect of these cascades. And we used an agent-based model to grow that pattern as a possible explanation for it.
So you're not saying that some questions are more cascadey than others. You're just saying that everything's, potentially in the real world, we're getting one realization of everything.
Cascade, no, items are more cascading than others, I think, based on just the rational herding paradigm, that to the extent that I sort of really know what I think on something and I don't need to assume other people know better than I do, I don't care what they said. I trust my own judgment and it won't be as cascading. On the other hand, if it's an item about which I really don't think I have the answer, I'm uncertain about it, I haven't thought about it, I'm just going to go along with what my fellow Democrats or my fellow Republicans are saying and take a cue from them. Those items will be more cascading. Also, I think, the wordings of these items are important. So just the clues that we put into it when we write it up can affect whether or not people will feel confident in their own internally generated responses. I think our big concern here is that so much of social science relies on surveys that have lots of information in them about individual attributes, and therefore our explanations default to these atomistic explanations that explain our politics. But your politics reflect your education, your socioeconomic status, your income, as if you were Robinson Crusoe and had no neighbors with those ideas. So that's kind of the hidden agenda here. Yes, please.
So you're presenting them with things that they've probably not thought about deeply.
Hopefully not, yes.
Which is great, but at the same time, when you think about real issues, I've had time to think about abortion, and I'm not going to follow Democrats or Republicans on that. I formed my own opinions. The fact that these things are being discussed doesn't mean that I'm, following everyone else, but I've had time to form my opinions on that. So do you think this would apply to issues that we constantly hear about and, are really critical?
Absolutely. If we could go back to if we could study you and all the other people who were forming those attitudes way back when they did not have pre-existing opinions. So if what we're trying to do here is to study the evolution of party alignment from zero.
But if I have something at stake in this,
once it's set, once the concrete has set, the concrete is set, and there's not much you can do about it. Here's what we're asking: where the concrete has set, is it possible that this is not necessarily due to individual attributes that would explain a person's position in that set concrete, such as gender, such as education, but rather to the fact that you live in Ithaca versus you live in Oklahoma City? Yes, Jill.
So, I buy the big picture and the message. The one element that I cannot understand is the following. So your answer to Duncan's first point was essentially, if the questions we come up with are totally orthogonal to partisanship, so don't hint people with words like regulation and so on, in an infinite amount of replications, we'll find them like taking off for Republicans, taking off for or Democrats, and not taking off for it. Correct? And then you said something like, but if there is any bias that triggers them, then that's actually against our theory.
Yes.
So it's strengthening.
Because cascades will always trip in the same way, and we won't get between world differences.
Yes.
So the tipping will always go to the left, and therefore all the worlds will be the same.
Yes, but you are also inducing partisanship. You are also inducing more within-words polarization, which is one of your elements.
That's what we're trying to do.
Right. Yes, but the point is like you are artificially boosting that.
We're creating it. We're creating
and
it. We're trying to create that in the Petri dish.
Yeah, but it
We're trying to
won't
grow
follow this
mold right
normal
there in the Petri dish.
distribution.
Pardon?
It won't follow the normal distribution. So it won't follow the idea that if you were to replicate the same issue over time, over a huge amount of words, you get a distribution of how they take off.
Right, but you know, when we administer a survey, we're administering that survey in the one world that we inhabit. And what the multiple worlds design asks us to do, and I think there's a passage actually in one of your papers where you frame it in this way, that what the multiple worlds asks us to do is, but what if? Could it just as easily have gone a different way? A question that we tend not to ask enough. And I think one of the most important contributions of Music Lab was that it challenged us to ask that question. Yeah, which I think we tend not to ask when we just look at data after the concrete is set. It gets reified, and we think this is the only way it could happen, and we think everything is obvious. So I think we're out of time.
Thank you.